Pad footing in structural buildings. Design, function, and importance. Introduction. In structural engineering, the stability of any building begins at its foundation. Among the various types of shallow foundations used in construction, the pad footing remains one of the most common and efficient solutions for supporting isolated structural loads. Also known as isolated footing, a pad footing is designed to safely transfer concentrated loads from columns to the underlying soil. This article provides a formal overview of pad footing in structural buildings, including its definition, components, design considerations, advantages, limitations, and construction process. What is a pad footing? A pad footing is a shallow foundation that supports a single column or a small group of closely spaced columns. It is typically square, rectangular, or circular in shape and constructed from reinforced concrete. The primary function of a pad footing is to spread the load from a column over a sufficient area of soil to prevent excessive settlement or soil failure. Pad footings are commonly used in low-rise and medium-rise buildings, where the soil-bearing capacity is adequate at shallow depths. Components of a pad footing. A typical pad footing consists of the following components. Concrete base, the main structural element that spreads the load to the soil. Reinforcement bars, rebars, steel reinforcement, placed within the concrete to resist tensile stresses and prevent cracking. Column starter bars, vertical reinforcement extending from the footing into the column to ensure structural continuity. Blinding layer, lean concrete, a thin layer of low-grade concrete placed below the footing to provide a clean and level surface. Soil subgrade, the compacted soil beneath the footing that provides support. Purpose and function. The primary purpose of a pad footing is to distribute column loads safely to the ground, prevent shear failure and bending failure in the foundation, minimize settlement, provide stability against overturning and sliding. By increasing the area over which the load is applied, the pressure exerted on the soil is reduced to within its safe bearing capacity. Design considerations. The design of pad footing involves several structural and geotechnical factors. 1. Soil bearing capacity. The allowable bearing capacity of the soil determines the required size of the footing. A geotechnical investigation is essential to determine soil properties. 2. Column load. The magnitude of the axial load, including dead load, live load, and other applied loads, influences the dimensions and reinforcement of the footing. 3. Footing thickness. Thickness is determined based on bending moments and shear forces. The footing must resist one-way shear, two-way, punching, shear, bending stresses. Reinforcement design. Reinforcement is typically placed at the bottom of the footing because tensile stresses develop at the bottom due to upward soil pressure. 5. Settlement control. Uniform settlement is critical. Differential settlement can lead to structural cracks and instability. Types of pad footings. Depending on structural and soil conditions, pad footings may be. Simple pad footing supports a single column. Stepped footing, used where greater depth is required. Constructed in steps. Sloped footing, tapered thickness to optimize material use. Combined pad footing, supports two or more columns when they are close together. Construction process. The construction of a pad footing typically follows these steps. Setting out, marking the location of columns and footing dimensions. Excavation, digging to the required depth based on design specifications. Compaction of subgrade, ensuring firm and stable soil support. Blinding concrete placement, pouring a thin layer of lean concrete for a clean base. Formwork installation, erecting molds to shape the footing. Reinforcement placement, installing steel bars according to structural drawings. Concrete pouring, casting high-strength concrete into the formwork. Curing, maintaining moisture to achieve proper strength development. Backfilling, replacing excavated soil around the footing after curing. Advantages of pad footing. Pad footings offer several benefits. Cost-effective for low-rise buildings. Simple design and construction process. Requires less excavation compared to deep foundations. Suitable for soils with good bearing capacity. Efficient for isolated column loads. Limitations of pad footing. Despite its advantages, pad footing has some limitations. Not suitable for weak or highly compressible soils. May not perform well under heavy or eccentric loads. Risk of differential settlement if soil conditions vary. Not ideal for high-rise buildings with large structural loads. In cases of poor soil conditions, alternatives such as raft foundation or pile foundation may be more appropriate. Applications. Pad footings are commonly used in residential buildings, bungalows and duplex houses, small commercial buildings, industrial sheds, school and church structures. They are particularly effective where columns are spaced widely apart and loads are moderate. Importance in structural stability. The structural integrity of a building largely depends on its foundation system. A well-designed pad footing ensures load transfer without structural distress, prevents cracking in superstructure elements, enhances long-term durability, maintains building alignment and serviceability. Failure in foundation design can compromise the entire building, regardless of how strong the superstructure may be. Conclusion. Pad footing is a fundamental element in structural building construction. As a shallow foundation system, it provides a practical and economical solution for supporting isolated columns in buildings constructed on stable soils. Proper design, accurate soil investigation, Adequate reinforcement and quality construction practices are essential to ensure its effectiveness and durability. Understanding the principles and application of pad footing enables engineers, builders, and construction professionals to create stable, safe, and long-lasting structures. The success of any building project begins beneath the ground with a strong and properly designed foundation.